I'm back, and so now we want to talk about how to date rocks relatively. So we cannot say what the dates of the rocks are going to be. So that's going to be numerically, which we're going to discuss in just a few minutes. But we're talking about which rock is older than another rock. So if we got two rocks, how can we tell which one of the two is going to be older? So the first principle is going to be called original horizontality. And so this is going to say that when rocks, like sedimentary rocks, are laid down, they're going to be laid down in parallel, things like that. And if you see something that has been tilted like this, then you know that the tilting had to have occurred after it was laid down horizontally. So tilted beds are going to be older than horizontal beds. Okay, then you got the next one is going to be called superposition. And so in superposition, this means that a rock layer, so let's say that this is rock layer A, and then this is rock layer B. Okay, A has to be older than what B is. So A had to be laid down first, and then B was laid down on top of it. Unless you have a situation where you could have a bed that is overturned. So that you might have beds like this, and then they're flipped over like this. Okay, and then you'd notice that the oldest layer, which would be, again, let's call this one layer A, that actually is the oldest one, but you notice that it is on top if you fold the bed. So sometimes you have to be kind of careful about using some of these principles. Okay, the next one is lateral continuity. And so lateral continuity means that if this rock is of a certain age, then this rock over here is of the same age. Lateral continuity. Then you have cross-cutting relationships. And so whatever rock is the one that's being crossed, then that one is going to be the older rock. So that if you've got a bed, and then let's say that for some reason you've got something like this where there is another bed that's cutting across it like that, well, this bed here has to be the older bed. Baked contacts. So we found out that when we talked about the formation of marble, that it occurred when you would have limestone, and then there was some kind of a magma chamber, and then the rocks around it, so this limestone would be turned into marble from the heat of that magma chamber. So what this is saying is that whatever is baked must be older. So these rocks, the ones that were turned into limestone, they have to be older than what this thing was, the magma chamber. And then inclusions. So inclusions are going to be older. So that if you find a rock, and let's say that in that rock are little pieces of granite. So maybe it's a sedimentary rock, and inside the sedimentary rock you find little pieces of granite. Well, those little pieces of granite had to have existed before the sedimentary bed did. And then those pieces of rock got incorporated into the sediments, which then made the sedimentary rock. All right, so if you want some practice with all of these different kinds of concepts, that's what this little figure here is for. So notice that the very first picture is very complicated. So you've got beds that are folded, you've got fault lines that are going across them, you have, looks like that there's a dike in there, and there's intrusions and inclusions are in there. So if you will just follow the geological history of that, it's going to take you step by step, and it's going to show you what was the first thing that happened, what was the second thing, what was the third thing, and so forth, and it's going to be using these principles in order to do it. All right, so now let's take a break, and when we come back, we're going to talk about how can you correlate rock layers from different locations.